Hey there, Mr. Dodd back, working through the function operations unit in pre-calculus. This one we're going to talk about graphing. I can translate and sketch graphs of parent functions. We've already gone over this section. The biggest difference is instead of actually showing the function like squared or cubed or the square root, it's just going to be a generic f. But the plus and minus in the beginning flips you over the x-axis. The A in the beginning is a vertical stretch or shrink. Plus or minus on the inside is a horizontal, or to flip over the y-axis. B is a horizontal stretch or shrink. C moves you left and right, and D moves you up and down. So basically what we're going to do is use the transformations above to identify any transformations. So I'm going to write them out. And then, so describe the transformations, sketch a graph, and then identify the value. This first part's a little bit challenging to read right at the very beginning, so I just want to kind of translate that. Basically, this is saying f of x is equal to x squared. So what that tells me is that I'm going to end up having a parabola. And then g of x has my transformations. So I know that my transformations are going to be left 1, down 3, and then vertical shrink of 1/2. Okay, and it's going to give me a parabola. So essentially, what this is saying is like you have all these transformations of this original parent function. That's why we call it a parent function. So my vertex is going to go left 1, down 1, 2, 3. I'm going to put that on there. So the 1/2 out in front, so I took care of these two things. The 1/2 out in front, instead of going up 1 over 1, or up 1 right 1, I'm going to go up 1 right 2, and up 1 left 2. Since it's a vertical shrink, my parabola is just going to be wider than it otherwise normally would be. I'm not worried about a bunch of points as long as you show me that it's wider and then you give me those 3 points. Now, finding g of -3 on the graph. G of -3, if I replace my f here with the value of f, which would be putting a square right there, that would be 1/2 times -3 plus 1 squared minus 3. So this is just me kind of combining those two. Equals 1/2 times -2 squared minus 3. That's equal to 1/2 times 4 minus 3, which is equal to -1. So if I go to -1, 2, 3, I should be at -1. So I immediately noticed when I calculated my value, which is correct, I should be going through this point, -3, -1. So that just tells me that the sketch of my graph is just a little bit off of what it should have been, and the slope that I used isn't where I should have been. So I'm going to fix that because I calculated a point, and that's one of the reasons why I like to do things like this is that I can check my work and make sure, oh wait, that wasn't actually the right thing to do to find the slope, and it turns out, yeah, so I just did the wrong thing when I was actually graphing the parabola. So this kind of kept me in check, which is a good thing to do. Now might be a great time to pause the video and try to do the second one on your own. So that you can have an idea of how to, or give an attempt, and then I'll put the answer up and you can press play whenever you're done. Alright, I'm going to start going through this one. The negative out front is going to flip me over the x, flip over x. This is going to be a horizontal stretch of 2. And then this guy is up 2. So those are my transformations there. If I was going to graph this function, I would go up 2, put my dot. And my horizontal stretch is just going to stretch me this way. So I'm going to end up looking something like this, just a little bit more steep than what it normally would look like, or a little bit more stretched horizontally. G of negative 3 means I'm going to plug negative 3, so this equals negative square root of 2 times negative 3 plus 2, which is equal to negative root negative 6 plus 2. As soon as we get this negative 6 here on the inside of a radical, that's going to give us an imaginary solution. So this would be negative root 6i plus 2. But if I have an imaginary solution, that doesn't actually show up on the graph. And that should make sense, because where is negative 3, x equals negative 3 on the graph? Well, it's over here. Is this function, my square root function, graphed anywhere along that line? And the answer is no. So I like to try to throw tricky things in there like that, just to make you think about what the graph actually means. So hopefully that's helpful and gives you an idea of what to do on these functions and how to describe them and sketch their graphs and identify a point. Sorry about my mistake over here, but just make sure you're double checking as you go through. And at the end of the day, they're just sketches, so maybe plug this point in first to give yourself another target.